We have a way of implementing binary operations and storing the results, but the computer needs a way to determine which operation to use and when. This is called an instruction. There are instructions such as add two numbers and copy this number. Computers use what's known as the von Neumann architecture, which means that the instructions are stored in memory as binary numbers amongst other data. For example, the instruction number 16 in base 10, or this byte in binary, might mean add together two 8-bit numbers and store the result. Instruction number 17 might mean the same thing but for 16-bit numbers, and so on. When the computer encounters an instruction, it will use a comparison circuit which we looked at in a previous section to switch on the logic circuit for the necessary operation. If the byte is equal to 16, switch on the add circuit. How does the computer know when a byte is an instruction or not? 16 might be the instruction to add, or it might be the number of coins in a video game. Well, everything has to do with the precise order in which the bytes appear in memory. First comes the instruction byte. If the instruction is to add, the computer will need the two memory addresses of the things being added and the memory address where the result is to be stored. Remember that memory is like post boxes for a big apartment building with a unique address on each byte. In the case of modern 64-bit systems, addresses are 8 bytes long. Therefore, the entire add instruction has one instruction byte and 24 bytes of addresses, 25 in total. On the other hand, if the instruction is to copy a number, it just needs to be followed by the origin and destination addresses, meaning the whole thing takes 17 bytes in total. The trick is that each type of instruction always takes up a set number of bytes, and crucially, the next instruction immediately follows on after the previous one. So when the computer encounters the add instruction, not only does it carry it out, but it knows that the next instruction is precisely 25 bytes long. To start with, the computer interprets byte number 0, the one at the very start of memory, as an instruction, and thereafter goes from instruction to instruction. Conversely, if there has been an error and the next instruction is not where it's supposed to be, tough luck, the computer will probably crash. How does the computer actually carry out an add instruction? The number from the first address is loaded into one input register and the second address into another input register. The add circuit is enabled and it does the addition. Then, after a sufficient number of clock cycles, the result can be written from the output register to the required address in memory. What happens if the instruction is to add two 16-bit numbers together? The computer simply goes to the address of number A, and instead of getting just one byte, it gets that byte and then one immediately after. The same for number B and the result C. A computer program is a collection of instructions and addresses to be done in order. The computer goes from instruction to make the program run. Let's look at a specific example, part of the game, which is just a program after all, where the player has a wallet with coins in. This is what the contents of memory might look like. Byte number 0 is the instruction to add. Then come two addresses, the address of the wallet total and the number of coins the player has just found. The third address is the wallet again. After the addition, the wallet total will be overwritten. No matter what, the computer will now interpret byte number 25 in memory as an instruction. It is another add instruction, the addresses of the wallet and an amount of coins the player has made from selling items, or the inputs. The wallet address is the output again. The next instruction is 25 bytes further along, at byte 49. The program keeps going on with millions of other instructions required to make the game function. In this case, the wallet total is being used a lot, so it will probably be held long term in the processor's cache, as well as the RAM. When the player saves the game, it will be written to a save file on the computer's hard disk. To summarize, the computer interprets certain bytes in memory as instructions for which operation to carry out. Computer programs are stored in memory. They are just large sequences of instructions, memory addresses and numbers. The computer goes from instruction to instruction like clockwork, always knowing based on the type of the current instruction how far along the next one is.